If you look in the resources section of this lecture, you will find this exercise sheet. Please try this exercise sheet before moving on to the solutions. You can pause the video now and try them. Now that you've tried the questions, let's look at the solutions. 1 Part A. I to the 16 is equivalent to I to the 4 times 4 plus 0, which is equivalent to I to the 0, and this is 1. I to the 29 is equivalent to I to the 4 times 7 plus 1, which is equal to I to the 1, which is I. I to the power of 54 is equivalent to I to the power of 4 times 13 plus 2, which is equal to I to the power of 2, and that is minus 1. I to the power of 131 is equivalent to I to the power of 4 times 32 plus 3, which is equivalent to I to the power of 3, and that is negative I. Number 2. Given x squared plus 6x equal minus 13, then x squared plus 6x plus 13 is equivalent to 0. It implies that A is equivalent to 1, B is equivalent to 6, and C is equivalent to 13. The nature of the roots can be found with the determinant. D is equivalent to negative 16, and in this case, it means that we have two complex number roots. The roots of the equation are x equal to minus 3 plus or minus 2i. If we let alpha equal minus 3 plus 2i, then alpha squared would be equivalent to 5 minus 12i. And if we let beta equivalent to minus 3 minus 2i, then beta squared would be equivalent to 5 plus 12i. A quadratic equation with roots x squared and beta squared will have the form x squared minus alpha squared plus beta squared x plus alpha squared beta squared equal to 0. So alpha squared plus beta squared is equivalent to 10, and alpha squared beta squared is equivalent to 169. Hence, the quadratic equation with roots 5 minus 12i and 5 plus 12i is x squared minus 10x plus 169. Number 3a. z1 plus z2 is equivalent to 2 plus 16i. z1 minus z2 is minus 2 plus 10i. z2 multiplied by z2 bar is equivalent to 13. z1 over z2 is equivalent to 3 plus 2i. Number 4a. Given that alpha is 5 minus 2i and beta is equivalent to 5 plus 2i, then alpha plus beta is 10, and alpha multiplied by beta is equivalent to 29. If the roots are 1 over alpha minus 2 and 1 over beta minus 2, then the quadratic equation would have the form z squared minus 1 over alpha minus 2 plus 1 over beta minus 2 z plus 1 over alpha minus 2 multiplied by 1 over beta minus 2. 1 over alpha minus 2 plus 1 over beta minus 2 is equivalent to 6 on 13, and 1 over alpha minus 2 multiplied by 1 over beta minus 2 is equivalent to 1 on 13. Hence, quadratic equation is z squared minus 6 over 13z plus 1 over 13 equals 13z squared minus 6z plus 1 equals 0. Number 5. If one root of a quadratic equation with real coefficients is a complex number, then the other root is the complex conjugate of the known root. So given the root 7 minus 6 root 2i, then the other root is the complex conjugate 7 plus 6 root 2i. Let alpha equal 7 minus 6 root 2i and beta equal to 7 plus 6 root 2i, then the quadratic equation would have the form of z squared minus alpha plus beta z plus alpha multiplied by beta equals 0. So alpha plus beta is equivalent to 14, and alpha multiplied by beta is equivalent to 121. Therefore, the quadratic equation is z squared minus 14z plus 121 equals 0. Number 6. Given z squared is equivalent to minus 4 plus 2 root 5i, we can get that x squared minus y squared is equal to 4, and I'll call this equation 1, and 2xy is equal to 2 root 5, which implies that y is equivalent to root 5 over x, and I'll call this equation number 2. If I substitute equation number 2 into equation number 1, I would obtain the following quadratic equation after some simplification. X squared plus 4x minus 5 equals 0. If I factorize this quadratic equation, I will get the factors of x plus 5 and x minus 1. But x minus 5 is invalid since x must be greater than or equal to 0. This means that the only valid answer is x equal to 1. But x is equivalent to x squared. So x squared equivalent to 1 implies that x is equal to plus or minus 1. When x is equivalent to 1, y would be equivalent to root 5, which means the first root is 1 plus root 5i. When x is equivalent to minus 1, it means that y is negative root 5, which implies that negative 1, negative root 5i is the other root. Hence, the roots of the quadratic equation are z equal to plus or minus 1 plus root 5i. Number 7. Given z squared is equivalent to 2 plus I, then x squared minus y squared is equivalent to 2, and 2xy is equal to 1, which implies that y is 1 upon 2x, and I'll call this equation number 2. Substituting equation number 2 into equation number 1, I am able to obtain the following quadratic equation: 4x squared minus 8x squared minus 1 equals 0. That means that a is equal to 4, b is minus 8, and c is minus 1. So x squared would be equivalent to 4 into 2 plus or minus root 5 over 4 into 2. So either x squared is equivalent to 2 plus root 5 over 2, or x squared is equivalent to 2 minus root 5 all over 2. Number 8. Given z is equal to 15 minus 43i and z2 is equivalent to minus 3 minus 5i, then z1 over z2 is equivalent to 5 plus 6i. So z1 over z2 squared would be equivalent to negative 11 plus 60i. Number 9. Given z is equivalent to 2x plus 5 plus 8i and z2 is equivalent to 13 plus 3y plus 2i, then z1 equals z2 implies that the real part of z1 is equal to the real part of z2, which means 2x plus 5 is equal to 13, so x is equal to 8. And z1 equals z2 implies that the imaginary part of z1 is equivalent to the imaginary part of z2, which implies that 3y plus 2 is equal to 8, so y is equal to 2. Hence, x is equal 8 and y equal 2. And that is the end of the solutions. If you have any questions or you spot any errors, please let me know.